should be able to do it. Hello, everyone. All right, let's give it a minute and we will get into things. How you guys all doing? Good.
Doing good. How about you?
Good. Doing well. Excited to hopefully see what you guys make in the next week or
Yeah,
two.
yeah.
Have you been building the site? How do you pronounce your name? Is it Kayhan?
It's Q Hunt, but just call it. You can just call me
Kayhan.
Q.
Okay, cool.
Yeah.
What have you been doing, Q? Have you been practicing a site or anything?
Yeah, I've been building a bunch of different stuff. Yeah, just toying around with all the different tools. Cursor is definitely nice, but yeah, I made like a website, and then I use since I like my expertise is in like infra and like cloud, I like used it to like deploy on AWS using Terraform. And
Oh,
like I've been
fun.
working with Docker too, like Docker Compose files, like it knows everything. So I'm like, yeah, it's pretty nice.
That's awesome. Yeah, it
Yeah.
really does know everything, which is kind of fun. And you can quickly just learn about whatever in the world too.
Yeah, yeah. So it makes me think like, sort of like on the news and stuff, like it's only like a senior job market type of things, like what's gonna happen to all the jobs in like a year from now? Because like 6 months ago, it wasn't this good. Like,
It's getting pretty good pretty quick, but
yeah,
I don't know. If you're smart, you can figure out how to use the tools, and then all of a sudden you're way more
yeah,
productive than most people. So I
yeah,
still
yeah, for
talk to
sure.
vast majority of I'm interviewing right now, and the vast majority of engineers I'm interviewing haven't used any of the AI tools or aren't doing anything. So the
Oh,
wave is still
interesting.
coming.
Interesting. You're interviewing for people at, you have a company?
Yeah, I'm getting a new business started right now. So
I see, I
we're
see.
interviewing some engineers, and yeah, the vast majority are still not using any of the cool new tools. So we'll
Really?
see.
Interesting.
All right, let's jump into it for everyone else. So feel free to go camera on if you guys want to, so we're not just staring at a screen of names, but I won't put too much pressure on you there. Today we're going to jump into a little bit of databases and then ultimately deploying. So Jimmy's going to show us how to deploy your apps to the internet. There's a few ways you can do this, but we'll do a couple basic ways. So this way you guys can make something and get it out there and share it with your friends, which is kind of fun. So first, let's jump into databases. And again, this is our second to last class. So next week will be our last one. My hope is for next week, you guys give me a thumbs up or a thumbs down, but I'd love to have at least a handful of people present some sites that they've built. It could be whatever. It could be a personal profile page site like we've been building. It could be some other side project. We'd love to see some things that you guys are building. So if you're up for it, give me a thumbs up or whatnot, or maybe send me a note. I'll pull you guys afterwards, and hopefully we can get a couple names out there willing to demo some things. So last week I was not here, but you guys went through some more AI tools with Jimmy, and I've got up here on my screen a little project website or like a personal website. I asked Cursor to style it and make it look like Tron. It did a good job going through and styling it, which is kind of fun. I've got a few pages here, an about me page. I've got some things that are not accurate, but thank you, Cursor, for filling that in. And then I've got a projects page that shows a bunch of projects, which is kind of cool. And then a contact page. And you guys played around with that contact form before a couple weeks ago, maybe 3 weeks ago now, before spring break, where we had it then send an email off to people. Now let's go ahead and let's look at our code here to see what's going on, just as a refresher. We'll come into our server.js file. Again, this is an Express.js application that's running. Taking a look here at our server.js file, we can see we've got an array of projects up top in the top of the file. And then we come down and find our projects route, we'll see that it's rendering the projects page over in our sidebar here, which is right here. And then it's passing in the projects variable, which we saw up top there. So that projects variable, that's here. That is how this page is rendering. Now, it's kind of a pain in the butt, as you might imagine, to write all of your data by hand at the top of your files to load into the apps. That is why they invented the database. So the database is literally exactly to its name, is just like a store of information for you. There's a lot of different kinds of databases out there. Some that you guys might hear about are MySQL, Postgres, or NoSQL. Those are probably three big ones. They're kind of two categories of databases, though. Your two categories are relational databases, and then not like Jimmy, what would you call them? Non-relational databases or like
Document based.
document
Yeah.
document database or non-relational, or you'd call it NoSQL too. All interchangeable words for the same thing. But relational databases are a way for us to store data relationally. And actually, I believe everyone on this call already knows how a relational database works. It is an Excel spreadsheet. This is a relational database, more or less. So relational databases, I'm going to give like a 5-minute overview, but I don't expect you guys to actually learn how these work. I think hopefully I'll just kind of tell you how they're used and like some basic info about it so that you can go read about it on your own. I think if we were to do this class again, we'd probably spend a few weeks on databases so you guys could see how those get spun up. But a database is a set of tables, and each table you can kind of think of like its own sheet. So this would be like, table one, and let's call this like a projects table. And then within that database table, we have columns. So what would be some columns here for our projects one? Well, some columns we've got would be an ID column, title, description, technology, image. So let's do ID, title, and description here. We've got ID, title, and description. Those are 3 columns that we have in our database. And then each row here is a new entry in our database. So you usually start with ID 1. You say, a project I'm doing is like my car project, and it says building a Jeep. Maybe I've got a cabinet project, which I'm, restoring some cabinets. Each one of these is called a record. So this is like an entry into a database, basically. Now, this is a Google Sheet, right? But I'll show you guys what a real database looks like. I've got one here running locally. This is called Table Plus. It's a free application you can use to browse databases on the internet. And you can see in our sidebar here, we have a list of tables. So here's all of our tables. I've got one table in this database called projects. And then I've got a handful of columns across the top. I've got an ID column, a title column, a description column, technologies, image, and created app. You can come in here. You could actually even just right click. You can hit new table. And I could say, let's call this table dining halls. Okay. And then let's add a new column. We can hit this new column button down here. New column we're going to do is name. And then you say what kind of data is going to be stored in this. We'll just do text data is going to be stored in this. And we'll say, yeah, this can be nullable. It can be empty. No, it can't be nullable. You always need a name for a dining hall. We can go ahead and save that. And if we come over, look, we've got two columns now in this new spreadsheet, this table, dining halls and names. And we can go ahead and we can enter in some data for it. So for the first one, say 1, and let's say, Eagle's Nest. I think that's a dining hall still. We can do 2. We can say lower dining hall. What's the dining hall on Newton campus called?
Stuart.
Thank you, sir. Let's put in Stuart. There we go. Let's save it. We've got 3 entries now here in our dining halls table. Okay. Now let's maybe make another table here. Let's make a table called workers. Okay. So we're going to call this workers, and we're going to have an ID column. Every worker is going to have an ID, and every worker is going to have a name too. So that's called a, name text field. And then let's say they have a dining hall ID. This is going to tell us which dining hall that worker works in. All right. I've actually never done it through the interface here. So Jimmy, maybe I might need some help.
Yeah, you got to do it after you save, I think.
Okay.
But make it an int first.
Make it an int first. Okay.
Yeah.
Let's go int 8. Okay. So we've got this table. Now we know we've got a dining hall ID 3, which is Stuart. So let's go ahead and try to connect these. So let's say we've got an ID of employee 1. Their name is John Smith. So that's going to be in the middle there. And then dining hall ID 3, which represents Stuart. I can connect this dining hall over here. One
Foreign
second.
key. Yeah, there
Foreign
you go.
key. And this is going to connect.
No, you had it. You want to
Oh, I
start
had
this
it.
as a local table. Yeah, there you go.
Reference table. So we're going to say this table here, workers, this column, dining hall ID, is going to reference the ID column on another table. And again, this is just like real basic intro to databases, just so you guys know some basics. But we're going to say, okay, this workers table references the dining halls table, and it's going to reference the ID column. And there we go. I can save that. Now let's come back to our data and take a look. Look at that. We got a little arrow. So if I click that little arrow, it's going to bring me over to the dining hall steward. So now we can see, all right, this worker, John Smith, works at that dining hall steward. And we can start filling up these databases with records for pretty much anything. And pretty much everything in the world is related to one another, one way or another. These are called kind of like pivots, like pivot tables in Excel. You can connect things across. That's a very foundational idea. And the big reason you have databases is for information you want to store over a long period of time, right? So if you're coming into your code base here, instead of us loading in the projects, what we would do is we would say, okay, we're going to do like a database connection, and we're going to get our projects, and we're going to say, get all the projects and load them in. This doesn't work right now. I don't have it wired up, but you would do something like this in your own project to load in all those projects. And then you could change things in that database, and you could always see the history of everything in the database too, which is nice for security. It's nice for stability. If your code gets broken here, you still have all of your data in your database. So usually these databases live on a different server. They're running on a different computer somewhere, storing all of this information for you. When we were building Aereo, we started the database at BC, and I think today that database now probably has billions of rows of data in it, which is pretty crazy to think about. And we started storing not just text, but you store images or links to images, files. You can store pretty much anything into these databases. And the real benefit is that you don't need to actually start typing everything out. So one thing I added to this page was a add new projects form. So we can submit a new project. Let's call it a test project. Or let's call it, build the student union at BC. I think that, or like, what's it called where they have like a place that you all hang out in? What am I thinking of? I don't know. Build the student like plaza or something. So they got a student plaza. Let's revamp the old plaza, and we can enter in some technologies. Obviously, it doesn't matter for this. And then let's hit submit. And there we go. It showed up at the bottom. Normally, though, when you hit submit, what's going to happen is you're going to send that data to the database. It's going to get loaded into the database, and your app's going to reload. We can take a look at what happened here, though. We can see that our post route for submit projects, which is where that form was going, said, all right, let's make a new project right here. We'll make a new variable for new project, and let's push that new variable into the projects array that we defined at the top of our file. Now, the problem with this is that if I were to reload this page, wait a second. If I were to restart our server here, I would lose this project. So if I come in here and restart our server, node server, and reload projects, that project data that we just made is gone. Because that project was just living temporarily in the memory of the server here. It was just living in this little array that we made up top. We wrote this out so this stuff stays, but that one that we pushed onto that disappears. That memory gets deleted. So you use a database to store persistent data that you want to store for a long time. And that's usually the general practice is you put that data over there. Any high-level questions on that? And more of just like the theory, I guess, of when you'd use a database, what you'd use it for. Happy to answer anything there. Have you guys used any databases before? Did they teach SQL in a like ISIS class? Or I guess they renamed it from ISIS to information systems or something.
I learned SQL in one of the business school classes.
Okay, they do.
Yeah, I learned SQL in like that business class too, but they don't really teach you how to implement it into like an actual, website or project. It's just like every class that you learn at BZ is all like very isolated from each other.
Yeah. Yeah, I remember taking our SQL class too. And the funny thing is most developers, you don't actually write SQL queries. So you
Yeah.
always learn how they work. It's good to know how they work under the hood, but most of the time and in most real companies, you're going to write them through some interface called like an ORM, which basically says, all right, we don't need to write SQL queries. Let's just tell the system what kind of data we want. We want to get users from this table that are above the age of 27 and less than the age of 50 to show in a report. And you can write it out kind of verbosely like that, and it'll get the data for you. That's usually how I write queries in the day-to-day. Jimmy, you probably use an ORM as well on the day-to-day.
Yeah, I was gonna try to find an example in our code base that's like clear to understand because I think it's worth looking at it really quick.
I
Here,
got one I'll show.
You got one? Okay, cool.
You got one in your code base?
Yeah, I was gonna here, I could show one in the code base really quick.
Okay, go for it.
All right. This is like relatively simple, but still I'll give some context around it. Okay, so this is a page that is loading. This one's actually maybe a little more complicated than I would have liked. Let's look at this one to start.
Yeah.
So this is a page that's loading a bunch of objects for a user. It's actually the dashboard page, right? So the user logs in, they see a bunch of stuff on the dashboard. This first query that's happening is we have a table called user team that associates users in their teams, right? So teams in our system are like basically accounts that users can belong to, so like companies, right?
So does every user have a team ID, Jimmy? Just like what we showed with the workers in the dining hall? And
yeah,
you should
basically.
say yes.
Yeah, exactly. Well, you don't want me to go into many. So we've got this table and we're querying user team dot find many. So I'm telling Prisma is the name of this ORM. ORM stands for is it Object Relationship Manager? I think that's what it stands for. It's basically it's an interface to SQL, right? So that we don't have to actually write SQL and it'll handle the typing of everything. So I'm saying, hey Prisma, from the user team table, find me many records where the user ID is equal to this other variable I have, but I could put like an actual number here, right? I could say user ID is 1. And then all that data from the database is stored in this variable right here. And then you can see it can get a little more complex too, right? Like down here, I'm saying find me flows, order them by the name, where, there's all sorts of like queries getting tacked on here, right? So it can get obviously more complex, but I think this example right here is like a pretty good one of like a pretty contained query where you could write this in SQL, but you don't have to with the ORM's help.
Exactly. And it's good to learn SQL. Like if you guys have a SQL class at BC, I'd recommend taking it. Very rarely do you get to learn the fundamentals of SQL. Hopefully then once you learn that, just know like they're not going to teach you like I forget who said it, but they're not going to teach you how to plug that SQL into real applications.
Yeah.
And there's a lot of tools around how you can do that easily. But it's good to know how the queries are written and structured so that you can then efficiently use these things like Jimmy showed you. It comes like a second language pretty quickly once you do that. But for like your guys' apps, what you're doing, I wouldn't recommend setting up a database right now. I'd recommend just putting it in memory and doing what we showed you guys. And you can scaffold in some data and arrays and objects with JSON at the top of your files just to get things working like how you want it and to start showing some stuff on there. Once you kind of scaffold it out like that, and I do that sometimes for simple apps first, then you can go in the process of structuring the database. Because usually the hard thing with a database is how do I want to structure things? And you usually don't know that until you do it. So it's kind of nice just to sketch it out. I pretty much make all my databases in Google Sheets or like the structure first and just plan it out there and map together the columns. And then once I have it down, then I'll write the code for it and I'll be good to go.
Yeah, most of the time suck goes towards like, at least for me and our team, goes towards like fixing the database schema when we learn something new about the product we're building or, the feature we need or whatever. Like you got to go in and add columns, remove columns. Like just the other day, we had to migrate a bunch of data between tables because we were kind of like combining features together. So a lot of the work is in these databases, but to Brandon's point, you don't have to know that to get started. Like you just have to be able to think about, where it might go at some point.
Hugh, did you have a question?
Yeah. I was gonna ask something similar along those lines, like whether, because like I know the design it like matters a lot with these relational databases. Like, like how much time do you guys spend like, beforehand planning it out versus like actually just like going and doing it and then like, fixing it as you go. But I guess you guys sort of answered that. So it's like, I guess it was like you mainly just go into it with like a rough outline and then fix it as you go
Yeah.
type of thing.
Basically. Like we did that with like production data too. So like
Yeah.
generally there's like a million
Uh,
things that can go wrong in a business. So you start with like the simplest one possible, and then once it starts to break, and usually their database will start to slow down. You'll see you go to a website and it just takes forever to load the website. And you'll see, oh, is that my server that's being slow? Or is it the database? Oh, the database is being slow. Maybe there's too much data in one of these columns, or maybe there's not like a proper formatting or a type or something. You can then work down a lot of stuff. I usually don't over optimize it up front. But like, I'll give you guys an example too. Like the new business I'm working on, we're planning out our schemas. We build these things called seeders, and then we click a button, and it fills the database with hundreds of millions of rows of data, and then it simulates thousands of users going to the site. So we can simulate in like a scenario, what does this look like at scale? How performant is this, and where will it break? And can you find any issues for me? So a lot of companies will do stuff like that and kind of test things out proactively as they're building it. But like the big problem where you're going to spend a lot of time in most companies is, let's say you want to rename a column from one thing to another, or you guys want to move data from one type to another. Like, welcome to like weeks of work of making sure that you can move that data, change the names across all of your code bases, and that it actually like stays up for users, because people are going to keep using it. They don't stop using it. So you got to make sure things are working. And you're basically like doing this like double switch behind the scenes, which is kind of fun. Lucci, you got a question?
Yeah, hi. I just had a question specifically about if you're building something that requires like query personalization or like personalized query execution. So something where, let's say, like content-based filtering, like a lot of the social media platforms do it. It's like a For You page or anything like that. If you're building something that needs the user input to then pull from that data, what are the sort of processes of that, and how does that work in this sort of context?
Yeah. Let me ask a clarifying question first. So, do you mean like how do you build like a personalized news feed, or like can you give me a better example, I guess, of what you're looking for?
Yeah, so like just for example, I have like a database right now of just 150 short form videos, and my goal is to get it to obviously like a bunch and to build a platform around it. But if I wanted to specifically create those videos to show up in the UI for a user based on a preference sheet that they put in, like they fill out a form, say their preferences, and then the videos that show up are specific to the preferences that they put in, what does that look like in that database? And are there like better data storage solutions to use for something like that? Or what would you recommend for that?
Yeah, great question. Jimmy, I'd be curious if you have any initial thoughts, and my brain is thinking right now on how I would
Yeah,
do
yeah.
that.
So I would do it like this. Let me pull up a Google Sheet. I think that, so what you're referencing at its peak is like collaborative filtering and like machine learning models that can detect preference. That's like way beyond, I think, where you'd probably need to start. I would do something like this. Okay, so let's say you've got a table called videos. Oops, can't type videos. And so you'd have like a name of the video and maybe like that, maybe that's enough for now, right? So video 1, video 2, video 3, right? Then you'd have a separate table called like tags or
Categories. Let's do categories.
Categories is probably a better word for it. Let's put that over here. So you'd have another table called categories with a name, and you could have a category of, startups, finance, right? Whatever the video is about. Then you'd have another table. This is a little more advanced than some of the stuff we started with, but you probably have another table where you would then need to link the videos with the categories, right? So probably like a video category table where you would have a video ID and a
Would a video though have one category or multiple categories?
Oh, good question.
Yeah, that's a good question. I was thinking of having just like one typically.
Okay.
Perfect. Even easier.
Simpler. Yep.
Even easier. Yep. So then you'd put a category ID on the videos table, right? Let me do this like this. Okay, so this is the videos. And that would point to, actually, you don't even need a category. So you can be even simpler. You don't even need a categories table then in this case. Let's just put a column on videos called category, right? And call it startups, finance, startups, whatever, right? And then when the user checks, like, I want to see videos about startups, I want to see videos about finance, you would query this table for videos that have a category contained within the types of videos that the user wants to see. Does that make sense? So the actual SQL itself, you don't need to like memorize this or anything, but would probably look something like select star from videos where category is like, or wait, you could do in.
It's
you could
in.
Do, yeah.
Yeah.
In. And then let's just say startups. So again, the syntax itself, you guys can look up and we use cursor to figure out, but you're basically saying, give me all the columns from videos where the videos category is in startups, comma, finance, right? Whatever other categories. And then that would just give a list for that user. Does that make sense? That's like the easiest way to start that I think would get you just to a point where the user could say, I want to see this, I want to see that, I want to see that. And then when your site blows up and you've got a gazillion users, you can worry about like machine learning models and the fun stuff around like recommendation engines and yeah.
Oh yeah, go for it, Lucci.
I was just gonna say, yeah, definitely that makes more sense. Like walk before or crawl before we walk, and then
Definitely.
walk before we run. So definitely, yeah. Thank you guys.
Totally.
The other thing you could end up doing too is, you guys ever see the movie Social Network? Classic movie. Every programmer, I'm sure. They built that Face Smash website where they're comparing people side by side. You could add a ranking system, and all you're doing is like a personalized weighted average across different objects. So you'd have each video gets a category, and then I would probably have like a user category weighting for it. So like as the user gives feedback, you're giving different weightings to different videos. And then you can show like a order of like, here's the like highest like related things to the user's rankings. Probably get a little complicated to figure out how to do it, but it's all just weighted averages and then just showing something that's close in proximity to that.
Well, definitely.
If I could ask,
Yeah.
if you're gonna like implement something like that, obviously, you can get super advanced with that. But like when you say like weighted averages, would you mean like the more that specific, I don't know, I forget what you said, video or something gets pulled from the database, like you would add to like its weight or like, and in the SQL table, or are you gonna like use something separate to like, and is this like for every single user has their own like specific weighted preferences stored in the table somewhere in the table?
Great question. So I think for the former, if you just wanted to make it like a YouTube platform, right, that surfaced popular videos, what I would do, and let's say popular is a little bit more complicated than just how many views it has, right? That'd be pretty easy if you just showed videos with the most views. Maybe it's like duration plus number of views plus number of likes plus number of comments. Those would be 4 different attributes. You could weight each one. You could say, hey, I'm going to give a 20% ranking to the number of views, a 50% ranking to the duration watched, a 20% ranking to the number of comments, and then a 10% ranking to the whatever else is left there. And then you could get a weighted average for that video in terms of like its overall popularity on the platform. Your second question now about how to do that as like a personalized would be much harder. And that's, I guess, what Facebook and TikTok and all of those platforms have gotten really good at building like an efficient, personalized thing. I would probably not use a database for that. There's probably other types of databases that you could use.
Okay. Yeah. That's sort of what I figured. And then, sorry, I'm asking a lot of questions, but
No,
I have one
go
more,
for it.
I guess,
I love
before
it.
you move on. Yeah, like, I mean, you guys have both, you and Jimmy have both like built businesses. Like, there's so many like database options out there. Like, I mean, I know, when you're choosing between like NoSQL or SQL, it's more basic, like structured versus unstructured data. But like, even when choosing between those, like there are just so many options, and even there are new like database companies coming out. Like, how do you guys decide to use that? And then maybe tied to that, like, what do you guys think of like backend as a service type things, like Supabase, like those type of things?
Yeah. Jimmy, you want to answer first? I got so many
Yeah.
hot takes.
Yeah, definitely. I think that Supabase is a lot better than Firebase in a lot of ways. Firebase is kind of the predecessor and like origin story of that kind of category. The reason I think it's a lot better is that Supabase is actually built on top of a relational database. It's on top of Postgres, and so you can use the database directly if you need to, as opposed to Firebase is built on top of a document-based database. And I think those are harder to wrap your head around in different ways. Generally, though, I think like maybe my hot take on this is, I don't know, like we scaled similarly in terms of database size and usage as Brannick did, my last company. And we never like really, like we picked our tech on day one and then never really changed it. And it was fine. Because I think the scale that databases are meant to support is way bigger than most of us will ever encounter with the things that we build and the, problems that we'll run into at that scale. So I think generally like Postgres, MySQL, like pretty much all good, and then if you have the right and the privilege to like care about the scaling concerns of that tech, then you've got lots of money and, other problems to deal with that like will solve that for you. So that's my like startup focused take on it is don't overthink it too much.
I see. So generally, at least for you use like the SQL over NoSQL.
Yeah, I've always been SQL over NoSQL. Yeah, I have never. I know some people really love it. I've just never been able to get into it.
Yeah,
I see.
I think vast majority of the time SQL is a better choice for most companies. Very rarely do you need a non-structured thing. They just don't work well when you have relational data, and you almost always do. I haven't been a big fan of the backends as a service, just because I don't think it's that hard to actually roll your own database and like deploy your own database on AWS. It's a little bit more setup, but once you do it, you kind of control it, which is nice. But if you guys are getting started, like I used a backend as a service for our first company at Area. We used Heroku back in the day, which would be like the equivalent of Supabase now or one of these other providers. So like it's definitely great for getting going, make it super easy. You don't have to deal with a bunch of stuff, which is the most important thing. We use Postgres always. The reason why, I just found it and then I just picked it and I did no research. And it turns out that was a phenomenally great decision and it worked out great. So I've been happy with that. We're building the next business in Postgres as well. They usually do a little bit better than MySQL, I find, for more abstract data types.
Yeah, I agree with that. And that's a good transition actually to deployment. Should we go there next? Unless there are any other questions, but that's a good segue.
Yeah, so for now, I'll add small questions in the chat.
Cool. Yeah, sounds good. Sweet. Awesome. All right, well, let's talk about getting your stuff hosted in the cloud so that you can actually share this stuff with friends and family and users and all that good stuff. So everything we've talked about up to this point has been deployed locally. Let me share my screen here and let's take another look. Okay. There we go. All right, so if I run my server like we've been doing in the past. Oops, 3001. There we go. Okay, so here's our to-do list, right? You'll notice, and we've kind of up to this point said, oh, just ignore this. We'll talk about it later. Today's the day we're going to talk about it. This has been hosted on localhost, right? If you look in the navigation bar here. Localhost just means that it's only running on your computer. If you are not running anything on your computer right now and you try to go to localhost 3001, you will not see what I'm seeing, right? This is not on the internet. So we need to find a way to take what we have built here and package it up and get it onto a server and some hosting platform that can actually serve it on the internet. Now, thankfully, Brannick referenced Heroku. We're going to use a platform called fly.io, which we'll talk about. There has been a stunning amount of progress in the last, call it 10 years or so to make it really easy to host what you've built on the web. This didn't used to be the case. It used to be that you'd had to way back, you'd have to provision your own literal server, go rent a co-located server rack and, try to rack it and do that. And then over time it got easier and easier. And now it's super easy, one command, we're going to see. So all that being said, if we take a look at Fly really quick, let me just show you Fly.io's homepage. So this is one choice of many. Some other choices that you'll hear of are Vercel, Heroku, I think Railway is another one. And then AWS, Amazon Web Services, is the big behemoth here. AWS, Google Cloud Services, Azure, those are the big clouds, right? You probably don't need to worry about getting onto the big clouds until there's something that's, like a reason to do that. Scale, security, a bigger team, whatever that is. These are great services for like getting started and then, going from there. To Brandon's point, it's actually like not crazy difficult to figure out how to host them on AWS or any other service, but this, as we'll see, is a little more designed for kind of like one command developer experience. So let's take a look really quick. I have this installed on my computer already, but if you want to follow along or do this later, this is how you can kind of get this command on your command line. There's documentation if you go to fly.io and find their docs. The accounts are free. I think you get up to $5 a month of like free servers, which actually goes really far on Fly because the servers spin down when they're not being used. So it's like effectively free. But let's take a look at how this works. So the magic of something like Fly is that you actually don't really have to know anything about like how this is going to get provisioned. Fly has done a lot of the hard work of helping you, of building a tool that will detect the technology that you're using and figure out how to get it onto their cloud, right? So again, I already have the Fly command installed, but I'm just gonna, in my repository here, in my terminal, in this folder, BC Web Apps profile pages, I'm gonna type Fly launch. I've not typed anything in this folder before related to Fly, so this is like starting fresh. I'm going to type Fly launch. And look at this. The first thing it's going to do is it has detected that we are using a Node.js app. So right off the bat, it has like figured out what best practice is going to be to get this up on their servers. It's going to give me a bunch of other settings here. Like for example, it's going to host this in the New Jersey region. I'm in New York, so it's figured out, like their region that's closest to me. It's going to put it on a machine that has 1 CPU, 1 GB of RAM. You could configure this stuff if you wanted to. I'm not going to because it looks good. But one thing I want to call out really quick is you'll notice Postgres right here. That's one of the database types that Brannick mentioned that we've been talking about. Fly makes it really easy to just tack on a Postgres database to your server here and connect to that database inside the same cloud, right? So their whole business model is they're just trying to make it super easy for you to consume these resources. But let's not tweak these settings. So I'm just going to type N and hit enter. And now what we're going to see it do is it's going to build this application. We don't, again, like at some point, it could be interesting to research like what's going on behind the hood here or behind the scenes. But it's like, I don't really have to know that much. Like I'm just going to let it do its thing. Let this build here. This is using, if you are curious, a piece of technology called Docker, which is a way to package up your apps. But again, doesn't really matter that much. And then here we go. This is actually telling me I can go to Fly and watch my deployment. So here's my Fly dashboard. I'm going to refresh. Here's my app that I just launched. Again, with one click here, and you can see it's deploying this and creating it. And this will just take a few more seconds here. Actually, it might be done. It's deploying now. Oh, actually, this is interesting. It might be angry that I'm not listening on the right port, but let's see if it was clever enough to figure out how to fix it. All right, so if I go to overview here and go to this link. Okay, I've got to fix this. So hold on. So let's do this together. So I'm going to go into Cursor in this project here. And I'm going to actually just ask Cursor, can you edit this to listen on port 3000? You might have, I moved on a little fast. You might not have caught it, but it told me, hey, you need to be listening on port 3000. So I'm going to pretend I don't know where to go to fix that. And I'm just going to ask Cursor to figure out how to fix that error for me. All right, looks like it's figured it out. So it was down here. So I was listening on port 3001. I needed to be 3000. So I'm going to hit yes. And then I'm just going to retype Fly launch. Oh, actually, you know what? Now that I have an app in here, it's actually just Fly deploy. So there we go. It's going to rebuild the app, re-push it up, and this should fix our issue. And notice how, again, like if I didn't know what was going on, I just asked Cursor just with the error message, right? So all these tools are learnable through Cursor and other AI tools. All right, we'll let this deploy. If we go flip back to fly.io here, we can see it's redeploying with the status bar up here. And then the cool thing about this too is, once this is deployed, you can actually come in here and add custom domains. I think you do that through, is it registry? There's a way in here somewhere to do it. I forget exactly where, but you can host this. You can buy a domain and host it on a custom domain if you want to do that. And then, okay, this looks like we're just about ready here. So let me open this up. There we go. So this is now my deployed app. I'm going to actually put this link in the Zoom chat here, and you guys can add some different to-dos. Q's got a good question. Did you Dockerize the app in Fly, or did you go over that in previous class? Great question. It did it by itself. So Fly detected which technology we were using and then just injected like a best practice Docker file for it. And I didn't have to know what that was or, you know, how it worked. But of course you could customize it if you wanted to. And then that link should hopefully be working for you guys. Maybe somebody give me a thumbs up if it's working for you guys, but awesome. So then same thing, if I add a new task, right? Hit test and refresh. There you go. People are editing it, right? Some of you are in there changing stuff as I refresh here, which is cool. So there you go. Now the app is live, right? And again, this is one of those things where if Fly does complain for some reason about really anything, you can just take that error and stick it in Cursor and say, fix my app so that it deploys, right? Destroy the world. So okay, there you go. Cool. Any questions on this? Call mom. I like that one. Oh, you know what? One interesting thing I'll call out here. This may have added, did this add 2 machines? Okay, so here's a really interesting thing and a side effect of us not use. So you'll notice as I refresh here, you guys are not editing this as quickly as these items are changing, right? These items are changing faster than all of you are editing them. There's a reason for that. Fly, in its attempt to get me to spend more money on its platform, decided to deploy 2 instances of my server. So it did not just put 1 server up, it put 2 of them up. And when a request comes into the website, it's deciding which of these 2 machines to send the request to. This helps with scalability. It helps with reliability. If one of these machines goes down, you've got the other as a backup, right? So it's good practice generally. It's overkill for something like this. What's going on is because we're not storing our data in a database, we're storing our data in memory, like Brannick talked about. We actually have 2 pieces of memory going on that are competing with each other, right? We have one set of data memory that's happening on this server, another set that's happening on this server. And sometimes when I refresh, I get the memory and the data from one of those servers. And sometimes I refresh and I get it from one of the other servers, right? And you can see it bouncing back and forth as those requests flip between those servers. So that's another really good example of where a database would fix something like that, because the database would just be its own server that, you know, has one instance that is the central source of truth of the data. And as many machines as you want would just talk to that one server instead of to each machine's individual memory, right? So that's actually is not something I planned, but that is actually a good example of like the downside of using a database. Yeah,
not bad though. Now,
Yeah.
I was just going to jump in quick, and while Jimmy was talking, I made an account on Fly.io. It took me 1 minute, super easy. And I figured here, we'll take some more questions in a second, but let me share my screen. Let's just open up a new empty, I made a folder on my computer. That is it. There's nothing in this folder. It's completely empty. There's not any files, none of that. Let's ask Cursor to build me an app. Hey, Cursor, build me an Express.js application, web application using EJS. Is that our templating?
Yep.
Templating language, EJS templating language, and that I can launch to Boston College students. Students should be able to go onto the site, create classes, and then other students can review and add comments on those classes as well. Make it look like BC colors, maroon and gold. We do not need to use a database and can do everything in memory. So while that runs, we'll see what it does. Do we have any questions? Anything
I have
you
a
guys
quick
are wondering?
question.
Yeah, go for it.
Jimmy, we did this last week. I can't remember when we made the Uber Eats site, did we just say make it look like Uber Eats, or did we feed in the website? Like
We
the
did give it a
URL?
screenshot. Yeah, so
Oh,
you
we gave
can
it a screenshot.
drag a
Okay.
screenshot into the Cursor chat here and it'll use that.
Can
This
you
is
give it
Yeah,
like
crazy,
just,
actually.
can you give it a website, Jimmy?
You
Just
can
that-
also give it a website. Yeah, and it'll go out and it'll look at the website. We just redid our marketing site at my startup. And previously, before AI, I 100% would have hired a consultant for it. And instead I sat and
Mhm.
gave it screenshots and like inspiration and stuff, and it just like made the marketing site that I wanted. It was crazy. It like
Wow.
blew my mind. So
That's
yeah.
awesome.
There is a
And
cool
to
site.
attach. Oh, sorry.
Oh, no, go for it, Amon.
Brandon.
Nope,
Just to
keep
attach
talking.
the screenshots, did you put him? Is it like in the chat? You can put it
Yep.
right there.
Yeah,
Yeah, you
right
see in the bottom
top.
right here, that
Yeah,
little
I see
icon. You can drop it in there. While this runs in the background, there's another site called bolt.dev you guys could check out. My building that I'm in blocks it,
Bolt.new,
I
maybe?
think. Bolt.new.
There you go. Yeah.
There we go. And you can just ask it to build anything, and it'll launch it for you too, which is kind of cool. Build me a simple marketing site for students looking to learn web apps. You do need to sign in. Bolt.new is one. Lovable.dev is another. And I can say launch, and it looks just like that does on our computer. They're spinning up a virtual cloud for us right now, building it out. Let's go ahead. Let's log back to Cursor. Let's see how it's doing. It looks like it's making folders, it's making files, it's running commands, it's interacting with my whole computer, all while I'm just not doing anything, which is pretty crazy. So that's keep running. Let's see which one finishes first. Anything else you guys are wondering though, as we're kind of deploying these two apps side by side?
You had a good question about like if there's ever a situation when it would make sense to use local memory storage and like caching and things like that.
Yeah, if you think about, you have the front end and the back end, right? We learned about that week one. You go to a website, it loads the front end of your computer, and then you send data off to the back end. Sometimes when you're building out complex forms and things, let's say you're building an invoice, for example, and you got a bunch of line items to add and quantities and prices, it may make sense to do all that in memory in the front end there. So all of it's being stored into a variable, you're adding all of your items. And then once you have the whole page built out, then you can hit submit and it'll send it all once to the back end. So that's usually when you'd see stuff happen like that.
Gotcha. And is that the same thing as caching? I mean, there's probably a small difference, but
Not quite. So caching is a way that you can, I mean, I guess there's a few kinds of caching, but if there's something that you're retrieving from your database constantly, so let's say you're constantly going to your database and saying, hey, give me the top 5 videos on YouTube. Well, that takes actually a little bit of time. Databases are very fast, but it takes time to do that. You could cache that response. So then it'll basically store it in memory somewhere else on your server. And instead of having to go all the way to the database and load the database, it'll just get it from memory there. So it's close to that. Now, caches usually only last, you can set a duration, but you can say, hey, keep this variable alive for 15 minutes. So if anyone for the next 15 minutes goes, give the variable back. If it's after 15 minutes, let's go to the database, let's get the data again, and then let's reload that variable so it's now cached again in the future. It's like both of these are still building out.
I see. So caching is more like
Recommend
Change.
pushing that for a lot of reasons.
That was Jimmy.
oh,
Go
yeah,
for
we're
it, Jim.
good. I don't know if that answered my question, but yeah, no, caching is more just still your database, but just at the edge and like CDNs, I guess. And then local is just like pure local at that moment. Is that like cookies is part of local? Or is that, I mean, these are just sort of tangential questions.
Yeah, it's a good question. There's a few ways you can store information locally in the browser. One's called local storage. Another is like a cookie. And you can store a little bit of information in that cookie or your session in your browser. They all kind of accomplish the same thing. I actually put them all in the same category of like being a database. It's just like, all right, this
Okay.
database is running in your computer. This one's running somewhere else. Some of them are slower, some of them are faster. So then it's up to you as a developer to kind of choose, all right, maybe if people are logging in, we'll put the things related to logging in right next to them in their computer. So that'd be like a cookie. It stays in your computer with like session details. Or if there's like a lot of data you want to load repeatedly, let's put that in a database, load in the database repeatedly then. Cursor's taking a while on this website. I wonder what it's going to build. You guys have any ideas for things you want to build for next week here, or anything you guys have been building? Have you been building any projects?
Yeah, I've just been like playing around, like giving it just absolute BS and crash and see what it spits out. But yeah, I mean, mainly I've just been like toying around, like building my website, and I had used like Webflow before, so that's why I asked the question in the chat, like what are you guys' thoughts on Framer and Webflows? Because like that was like pretty big, but like it almost seems like it does. You could do everything that you need to in Cursor. So I don't know. I mean, like besides like the basic designing and stuff, like actually I don't even know where I was going with it. I feel like it can do like everything you just throw at it. You just have to know like a high level of, I don't know.
Exactly.
That wasn't a
can-
question.
Yeah, exactly. I mean, you can see here level.dev just built this whole website for us. We could talk to it and ask it to change things. You've got tabs here. Tabs are stored in local memory on your computer. So it says, which tab selected, your front end tabs. That's just on your computer. So it's super fast. So it keeps track of it there in your browser for you. Or searching, I bet the searching happens in your computer too. So we send all of the courses to your computer. They load into your browser. And then as you search, it'll search against local memory here to find which courses match that, instead of going to the server and fetching different courses and turning them back. But if you had 1 million courses, go to the server, search them there. It's gonna be faster, and then send them back the results to the browser. That's like what Google does.
Do you know what the difference is between like Lovable and Boltar, or are they like similar competitors, you say?
I think pretty similar competitors. Jimmy, you probably use both more than me.
Yeah, I find them to be pretty much the exact same. They're both scaling really quickly and going after the same kind of target market.
Gotcha.
There
Check
you
it
go.
out. We've got
Now look at this.
Looks
computer
just like Agora.
science, right? Let's see here. We got that. We can view details, and then you can add reviews. All right. Now let's go back to Cursor and let's tell it to deploy. So let's do what Jimmy said. Let's say fly deploy. Haven't done this yet. We'll hit
Oh, never seen that before.
that's weird. Let me try this. Blue.
Huh.
Okay. We'll try brew install fly.
I think it's fly CTL.
Oh, thank you.
That might be it. Yeah.
Yeah, 1 second then. All right. A brew install fly dash CTL.
One word, I believe. Yeah. Yeah, there you go.
There we go. Thank you, Jimmy. I just installed some virus. New BC project. Then we'll do fly deploy. There we go. We'll continue. Good to go. I'm logged in.
Oh, you got to do fly launch on your first one.
I see.
So when you guys first have one, you do fly launch, and then when you're ready to keep pushing it up on subsequent pushes, you can do fly deploy.
Gonna say no. And there we go. It's starting to build. And again, this all happened in the last 10 minutes. So I'm really hoping all of you guys show up next week with some cool app to show off to the class. It'd be even better if you had a URL that you could share with everyone. So this is building now. And we'll go back to our dashboard and let's see if we can see our app here now. There we go, new BC project. It's building. And let's see if we can send you guys a link. There it is. I think it's still building, but starting to get hosted. While we guys have you, is there anything else you guys would want us to go over next week besides kind of going through some projects? Is there anything you guys we didn't cover? I know we went fast through a lot of basics, but anything you hear about that you'd like to learn some more about?
Yeah, maybe like how you guys decide on like tech stacks, and then maybe also, there's like Bolt, Lovable, Cursor, all those things. How you guys, I mean, using Postgres, like AWS, like there's so many different abstractions that you can use. Like, what do you guys decide which to go with?
Yeah, we can definitely cover that more in depth, and maybe we can make a little roadmap for people, Jimmy.
Yeah.
Some tools out there and like what you can do with what, so you can kind of have a place to go. I
Good
would
idea.
say at a high level though, like generally just picking something and running with it is the best.
Totally.
And like you can't go too wrong. Like you can get pretty much everything done with everything. And that's the best way to learn too. You'll figure out pretty quickly whether it works for your situation or not.
I always loved the advice that you heard me say it earlier that somebody told me once, which is like when you have the problem, like you'll have money to deal with the problem. Like you can like earn the right to care about the problem, you know, the like super nitty gritty parts of it later on. The startup side of it, at least beyond just, you know, different philosophies on like doing like a day job for engineering, but at least on the startup side, the key is just like get moving as fast as you can on something to start proving stuff out.
Quick one other thing.
Or
Sorry.
yeah.
Back, I think it'd be cool here is maybe just like anything like after you kind of get past the stage of like just creating like a mock website or like deploying it of like once you become like a full scale company, I guess like the biggest things I guess that maybe you guys have run into that you kind of wish you knew or anything that like would be helpful. Like say we got past the stage of just having like a website that we could show people, but that was an actual app or like a real application for like kind of large scale use.
So Brannick, we can put together like some like startup resources, some AI resources, and like talk a little bit about the startup roadmap and how it typically plays out, and then see some examples that you guys build too. It might be good pulled all together.
Yeah. Yeah, I think that'd be perfect. You can definitely jump into all of that. Have you guys heard of Soaring Startup Circle? You know, they do some stuff on campus, right? SSC.
Yeah.
You might have heard of SSC. Let me see if I can pull up their website here. Soaring Startup Circle BC. So this is a group. They a bunch of BC alumni, Tom Coburn, namely, and a handful of others, Peter Bell, started this a while back. And if you guys are students, which you all are, they do a summer accelerator program too. So if you have a business you want to start or an idea, they'll give you some money and they'll help mentor you. And you'll work with people like me and Jimmy throughout the summer to get mentored and just like to work on actually building the business. And my hope is to help on the tech side more so going forward. There's usually about 3 to 5 different companies that they take. And you really don't necessarily need any progress so far, but if you came in with a good idea or something you want to work on, or even if you need help, maybe working an idea, let us know. If you're interested in this, just reply to one of my emails, let me know. We can get you guys in touch with Tom or give you some more details on this too. I think they give you
That
what,
just
like
for-
$5,000 or $10,000 for the summer, maybe.
Something like that. Yeah.
What was that, Q?
I was gonna ask, is that like just for students in between or like post grad? But I mean, I guess, but it makes
Post-grad
sense
as well.
for most students.
Yeah,
Yeah,
it should
but
you
it's,
just have to be affiliated with BC in some way. Don't have to be a current
see.
student. Yeah.
Yeah.
You do have to go full time on it. Like the summer program, at
Yeah,
least
yeah.
the expectation that you spend the summer full time on it. Yeah.
Yeah. Last year, though, there was, I think, 2 teams that were not students actively. They were alumni, and they were working on their businesses. So,
Interesting.
Oh, there you go. Thanks, Lucci. Yeah, there's details. So 10K for 2% equity.
yep.
That is $10.
Not $10.
Yeah. Yeah.
$10 for 2% equity would be a good deal, though. Cool. All
BC
right. Well, I know we're
special.
at time.
I'm willing to invest in that.
I get it. Yeah, me too. If I'll make that deal with anybody. Cool. Anything else to wrap us up here?
Right.
All right. Well, we'll see you guys next week. Looking forward to seeing what you guys build. This will be fun.
Yeah, it'll be great.
Yeah, yeah.
All right.
Sure.
See you.
All right.
Thanks, guys.
Yeah.
Everybody.
Thank you.
Yeah.
Thanks, guys.